Welcome to Strength in Concrete, the podcast presented by the Post-Tensioning Institute, recognized as the leading authority in advancing the post-tensioning industry. In today's episode, PTI engineer Brandon Harman sits down with PTI past president and fellow Jack Graves at World of Concrete to explore the benefits of post-tension sport courts. Graves explains how post-tension concrete stands up to temperature changes, soil movement, and flexural stresses, reducing cracking and minimizing cracks. The result is greater durability and lower maintenance than asphalt or conventionally reinforced slabs. They also cover the practical side, capping existing courts, preparing the subgrade, and choosing the right slab thickness, plus the growing use of post-tensioning in pickleball courts, running tracks, and full sports fields. Whether you are a sports enthusiast, engineer, or construction professional, this episode delivers valuable insights. Let's join their conversation.
Welcome to another podcast here at the World of Concrete by the Post-Tensioning Institute. My name is Brandon Harman. I'm a PTI engineer. I joined the Institute a couple years ago after being a consultant for 10 years. Today, we're going to talk a little bit about post-tension sport courts, and I'm joined today by Mr. Jack Graves. He's a PTI past president and PTI fellow. He's been doing this probably longer than I've been alive, so you've got a ton of...
quiet.
You've been doing this a long time, and you're a great resource and person to have join us today and talk about this. You want to introduce yourself and tell us a little bit about yourself?
Yeah, it's great to be here today. I've been involved with the post-tensioning industry for probably close to 50 years. Been involved with PTI for going on 40 years. As he said, I've been past president, been on a lot of committees and so forth, specialized in slab on ground applications, worked for some of the best companies in the industry over my 50-year career. Pretty fortunate and glad to be here today to talk about sports courts.
Yeah, we're glad to have you today. So with PT sport courts, can we talk a little bit about their advantages when it comes to long-term durability and lower maintenance and sustainability?
They have a lot of inherent benefits just because of the nature. The long-term durability, concrete in general, concrete structures are known for their durability over other products. While court slabs are not a structure, they don't carry any loads other than the limited live loads. They benefit from the same durability of the concrete. You basically went from everybody did asphalt courts in municipality type situations or private. Asphalt's totally unreinforced. It's very susceptible to a lot of movement. It's susceptible to changes in heat and cold and climate things, and they just don't last very long. So we do a lot of caps on asphalt courts. Then you went into concrete courts, but they're reinforced with traditional rebar. I look at rebar as like a static system. It's not really doing anything. It's just laying there static until you get movement, concrete cracks, and then it comes in and holds the concrete together, basically. But once it cracks, it's going to hinge and move back and forth with the weather cycles, heat and thaw, that type of thing, and causes a lot of problems, especially with long-term maintenance. But we started doing probably the first post-tension concrete court that I know of. We did probably back in the mid-'80s, early '80s. And because it compresses the concrete, it's not as susceptible to cracking. And when you do get cracks, they're held tight, so they're not a maintenance problem like you have on a conventionally rebar reinforced concrete slab. So it's just inherently durable, and the sustainability issue is addressed just because of savings in the concrete quantities, steel quantities, labor, all these things. So it's a very unique system, works very well with sports courts.
Yeah, I wanted to touch on that and expand a little bit how a PT court, comparing alternatives when it comes to material, labor, and construction savings, PT court versus asphalt or a mild reinforced court. PT court saving materials, generally thinner, but still provides the same performance.
Yeah, you save, it's pretty substantial what you save. A 6-inch conventionally reinforced design is usually if you took a 6-inch conventionally reinforced design slab, you can do the same thing with a little over 4-inch PT slab. So that's about a 28% decrease in concrete, which is substantial. The other thing with the steel quantity, a rebar slab is probably 2 to 2.5 pounds per square foot of reinforcement, or a PT slab is about a half to 0.6 of a pound per square foot. So you're talking a huge difference in steel, the handling, the delivery, the placement. You're saving all these things. The labor, obviously you're going to save in labor because you don't have as many pieces that you're putting in. PT is a little different and you have to nail up anchors and do those type of things. But once a crew gets used to doing it, it's very simple. It's actually a lot simpler than people think. It's kind of hard to mess it up. With a little experience, a little education, it's a very easy system. So it saves a lot of money, and it's not just the initial cost. Long term, like I said, asphalt courts don't seem to work very well. They're always having to be patched. They wear in certain places. There's just a lot of long-term maintenance with asphalt. Same thing with rebar reinforced. You get cracking as those cracks move back and forth during the seasons. They have to be routed out and grouted, and then you got to redo the surfacing. They're just a real headache. With the post-tensioning, you don't get many cracks. If you do get cracks, they're tight, so they just tend to last longer. I've got courts that we've built back in the early to mid-'80s, and they're still functioning perfectly. Asphalt courts won't do that. Conventionally reinforced usually won't do that either. So it's a very good system from a sustainability standpoint, and the long-term maintenance is one of the big places you save a lot of money.
Yeah, so saving on materials up front, but still having a good, high-quality product in the long term.
Yeah, like I said, concrete is just known to being a superior material when it comes to sustainability. That's in high-rise structures and bridges. That's why bridges are concrete typically. They just last so much longer. You get the same benefit from the concrete in a slab for a sport core. They're flatter. They're easier to get flat. They just last longer. They're just an all-around better system.
Okay, so we've talked a little bit about the advantages, long-term durability, some advantages to material and labor, but I wanted to talk a little bit about scenarios where a court's built on over the top of an existing court or different subgrades. They can really be built on any subgrade or even over the top of existing courts.
Yeah, a lot of times we will cap an existing asphalt court or an existing old concrete court that's rebar reinforced. There's no need to take that out unless it's just really a mess. And just think of it as you went in and did a subgrade prep. So you save, here again, a sustainability standpoint. You don't have to demo it. You don't have to haul it. I know a lot of asphalt and concrete is reusable, but you still got to demo it and haul it off. So if you can use the existing slab as your quote base subgrade, you save the owner a lot of money. I would warn you that you got to look at it. Since you're capping it, it's going to be an elevation type situation. There are some ADA specifications and stuff with the handicapped that you have to look for. We have had instances where because of ADA stipulations, we couldn't cap a court, but those are far and few between. On new construction, they're typically build up the subgrade. You want proper drainage. You want a good subgrade so you don't have soft spots, those type of things. And then you put poly as a friction to break the friction and keep moisture from coming up through the slab and pour your concrete court. And most of your courts are 4 to 5 inches thick. We prefer the 5-inch thick. It just gives you a little more fudge as far as your clearances and so forth. 4-inch slab has to be pretty much perfect. And so we prefer the 5-inch. 6-inch, we do some 6-inch slabs, but that's usually where they're using the court as a multi-deal. They're going to use it for a parking lot or move heavy equipment in for lighting or something, and they're worried about punchy shear. But you really don't need a 6-inch slab for strength or to play tennis on. So 4 to 5 inches is the common.
Yeah, we do get that question a lot is when would you need a slab that's, say, thicker than 5 inches, and you hit on it. Just if it's got some other structural load, like a vehicle or even maybe some bleachers, you may go a little bit thicker, but a standard general typical slab is 5 inches thick. For design and construction of post-tension concrete courts, we have publications at the Institute, DC 10.3 being one of them. Can you maybe touch on how this guide, maybe touch on this a little bit more and how we can learn a little bit more about this?
Yeah, the DC 10 publications are one of the best publications we have. It's very good. It covers a lot of topics. The design, which is pretty basic. It's not, you're not looking at any structural loads coming down on it. So it goes in with the design, talks about documentation, plan specifications. It has sections on the material, post-tensioning materials, site prep, construction topics, troubleshooting, landscape and maintenance, which is important for any slab on ground application. The maintenance and subgrade prep are really important. And then it has a lot of reference sections giving typical plans, elongations, those type of things. It's a must-have for anybody who's going to do a tennis court. It's available off the PTI website. In fact, they may have some for sale here at the World of Concrete. But it's a very good publication. You got a lot of details, a lot of photos, and a lot of great ideas. I highly recommend that you get it.
Yeah, so from, like you said, from planning and design all the way through documentation and construction, it gives all the industry best practices and standards to hopefully come up with a high-quality product in the end.
Yeah, it's a very good publication. We get a lot of good compliments. We also, the ASBA sport court folks, they reference our manual in their manuals. So we're kind of the Bible of what to do with PT concrete courts. A very good publication, and recommend everybody get a copy of it.
So with the 40 years that you've been in the industry, can you summarize a few case studies where PT's been used and it's been a benefit to the owner and the construction team versus another system?
Yeah, probably, like I said, the tennis courts they're pretty much typical. They're not all the same, but they're pretty much generic. But we've done a lot of courts for the big universities that want the top of the line. Even your high school now, with all the money in high school sports, they're going to PT concrete courts. The biggest trend we see now in sports courts are the pickleball courts. And we're seeing a lot of those, even for the residential people. The public are putting them in their backyards. And so we're seeing a real increase of pickleball courts. They're a 30 by 60 slab typically, or they'll build a tennis court and you've got 2 pickleball courts. But seeing a lot of that. We have done a lot of other sport applications. We've high school running tracks, college running tracks. We're doing running tracks now. That's a real popular thing going on. We actually did a softball field, the whole field, with post-tension concrete. And then they put the fake synthetic grass with some type of cushion underneath it. That was a real unique project and went real well. So I think you'll see more of PT applications because of the long-term durability of it used in any kind of sport, soccer fields, rugby fields, football fields, you name it. We also did some unique, different sports. Back in the 80s, I did a swimming pool, an Olympic swimming pool up at North Lake Junior College in Irving. And people ask, how can you do a swimming pool? PT is very unique in that we do a lot of circular structures with water tanks, gas tanks, grain silos, those type of things. So as long as the cable's in the center and it's designed right, you can do all sorts of creative things with post-tensioning. We also did a NASCAR track, half-mile oval NASCAR track, which is a sport. We also did a drag strip in Ennis, Texas, called the fastest quarter-mile concrete track. And so it's very flexible to use in a lot of applications with the right design. But I see a big future in post-tensioning with the running tracks and the sport fields. A lot of good use there because it is so durable, and you build it, it lasts for a long time. If it's built right, obviously everything has to be done right.
Yeah, expanding on Bill, that's with anything. If it's built right, it'll perform. Can you highlight how our certification program was advantageous for contractors and consultants both
Yeah, any training is good for the contractors. It's also good for the city municipality inspectors, private inspectors, engineering companies, subcontractors. It's just a good thing to get. I know that the people that we deal with that have certified employees just turn out a better product. The post-tensioning is not that hard to do. It just takes a little bit you need somebody there that can guide you through the first ones. Most of your PT suppliers will work with you, come out and help you with your first install or do an inspection of your installs before you place concrete. But it's very simple if you just follow half a dozen key elements of it. It's very simple. And it's from the standpoint of labor, like I said, you're putting in 25% of the weight of steel that you're putting in with a conventionally reinforced slab. So the labor-wise, it's a lot less. And it's just a very easy system. There is a stressing component. You do have to stress the cables. That's an added component. but you have savings elsewhere, so it makes up for that. But the certification program specifically, there's different levels of certification, but if you can get one or two of your employees certified and supervise the other people, it really makes a big difference. It also gives you some credibility when you're bidding work or working with a client that you have certified people on board. And they're very good classes taught by real experienced people. You do have to renew it. It's not a one-time shot, but it is a good thing to have, and we highly recommend it.
Absolutely. Yeah, I think there's a little bit of a misconception that post-tensioning is unsafe or hard to do, and these certification classes really help. I think people get a lot more comfortable after they've been through the class to understand, and that it really is safe as long as you follow the procedures, and in terms of performance long-term, as long as you follow all of our recommendations, it will perform long-term.
Yeah, no, it's a very safe system. Like I said, during the stressing, which most of the stressing is done through your post-tensioning material supplier. There are companies that do their own. When you're doing stressing, you definitely want to have your people certified and trained, because those could be dangerous if somebody's really not paying attention, but it's not hard to do. It's a very simple process, but it's one place that you would want somebody that has some experience in it.
Right.
But like I said, probably 80% of the jobs that we see, the PT supplier does the stressing operation. And then there's some guys who have gone to the expense of getting the equipment, and it does save coordination and things like that. But it's really a very simple system if you watch it. But it's like anything else, anything new or somebody's trying for the first time, they're a little skittish of it. But you also got to watch out for the people who tell you they know how to do it and they don't have a clue. So you got to watch out for those guys too. And that's why if you first get into it, it's nice to have your PT supplier do an inspection, come out during the install to make sure that the contractor really does know what he's doing. But a very simple process, and it's a very durable system that really saves a lot of money, not necessarily up front. It does save concrete quantities and those type of things, but the big benefit of it is long-term. It's just a very durable slab that's going to be there for years and years. If the drainage is good and the soil conditions aren't too bad, you don't have to do a lot of remedial work on the soils, but there are the limits. There's some soils in Texas where I come from that have plasticity indexes up to 65, 70. We try to limit our normal designs to PIs of 45 to 50, and it works well. But it's just a very good system. And I've never had anybody really complain about anything. And we've done thousands of tennis courts over the years and haven't had any complaints from anybody. Just the opposite. We get a lot of the coaching. The tennis coaches really like it because it gives you a really good surface and it doesn't move around as much as some of the other systems.
Yeah, and it gives you a good surface there's countless different products and things for the playing surface, but it gives a good surface for all of those different coating applications and things like that, as long as it's finished right.
Yeah.
It gives a good surface to put those on.
Yeah, and we always coordinate with the surface, with a tennis court. So what surface they're going to use, and make sure that the concrete is applicable to that surface. You do have to be a little bit careful. Sometimes some of the curing agents you can use kind of keep the bonding from the surface. So we try to coordinate that we're not doing anything with curing agents and those type of things that's going to hurt the surface, but that's very rare. We haven't had any of those if it's coordinated with the surfacing companies.
Yeah, the sooner that you can coordinate with those folks, the better.
Yeah.
So for future trends, do you see anything new and exciting upcoming in sport courts, or anything new in terms of post-tensioning courts?
Like I said, as I mentioned earlier, the baseball diamond, not the diamonds, the whole field, baseball, softball, soccer, football, rugby. We're doing a lot of tracks, running tracks. Those become real popular. And it's not just the running tracks. Usually at the ends of the running tracks, you have the discus and the shot put areas. Those are usually post-tension concrete too. And so that's where we see the growth. And then, like I said, you didn't see a lot of private tennis courts. You'd see one every once in a while, but we're seeing a ton of pickleball courts. People are building those everywhere. They're also taking existing outbuildings, these barn dominiums and stuff, and people are resurfacing those with a PT court for their pickleball courts for an indoor court. we're seeing a lot of that too. But I think the big deal is going to be the baseball, softball, and then the fields. It just, with the new surfaces and cushionings they have, everything's artificial turf now pretty much. And so we put artificial turf. The clays in Texas are probably about as hard as concrete. So you can put the surfacing and the mats on there, and that's what they're doing with football. So there's a lot of benefits to doing the post-tension slab underneath those fields. And I think we're going to see a lot of that in the next 5 years.
That's interesting. Yeah, I know, like we touched on it, tennis courts and pickleball courts in the last 5 years or so has really taken off. But yeah, the football fields and softball fields and those kinds of applications, that's one that's you think will gain traction. And is that just because it's the post-tension core just provides a good, solid, level surface for the turf?
What you're seeing, especially in high school and college and country club applications, they build a tennis court and they see how well it performs. So they say, hey, why can't we use it on some of this other stuff we do? And that's kind of where it's coming from. The architects, the engineers, the contractors are seeing how good the tennis courts are doing. And they're saying, hey, why can't we do that here? And so I think you're just seeing it kind of spread into other areas. It's just a very good system. Upfront savings, long-term maintenance cost reductions. It's a very sustainable slab. It's just a lot of inherent benefits from doing a PT reinforced slab, concrete slab.
Yeah, and you can build it on any subgrade. Subgrade prep is important, obviously, but it can be built on any subgrade.
No, it's a very good product. But here again, if you got to do it right, the concrete has to be good. Your contractor has to install it right, anything else. But usually concretes are not something that are a cheap market. So usually the contractors that do tennis courts, they're pretty good. They know how to grade properly, finish properly, and they care about what they're doing. And so it's a high-end concrete slab. Country clubs, schools have the money to do them right. And it's just a very good system.
Jack, appreciate you joining us today.
Yeah, enjoyed it. Yeah, anytime.
And that's all we have for today. We thank you all for joining us.
Thank you. Thank you.
Thank you for joining us today on Strength in Concrete, brought to you by the Post-Tensioning Institute. We hope today's discussion provided you with valuable perspectives on the advancements and opportunities shaping our field. If you would like to deepen your knowledge or explore additional resources, we invite you to visit our website at www.post-tensioning.org. If you enjoyed this episode, be sure to subscribe to Strength in Concrete on your favorite podcast platform and enable notifications so you never miss an update. Until next time, this is Strength in Concrete, your trusted source for post-tensioning expertise. We look forward to connecting with you next time.